In this video, we discuss the answers of the MCQ paper of the year 2010. Question number 1. The dimensions of moment of inertia. Moment of inertia depends on the mass of the object and the distance square. So, the dimensions of moment of inertia is ml square. Answer 1. Question number 2. SI unit of the quantity of heat. Heat is energy, so the unit may be calorie or joule. So they ask for the SI unit, so answer is joule. 4. Question number 3. Which color deviates the least when the white light passes through a glass prism? So to answer this, remember the color spectrum. The colors are in the order of Vibgyor. The red light will deviate least. So red is not in the answer. Next to red is orange. The answer is 2. Question number 4. The distance from the eye lens to the retina is given. They ask for the focal length of the eye lens when the eye is in completely relaxed position. When the eye is in completely relaxed position, the person is looking far. When the person is looking far, the parallel light rays coming to the lens converge at the retina. So the answer is 1.7 centimeter, that is 5. Question number 5. Three statements are given about a voltmeter and an ammeter. A. A voltmeter has a large internal resistance and an ammeter has a small internal resistance. That is true. B. A voltmeter is connected in series with the circuit component. No. The voltmeter must be connected in parallel with the circuit component to measure the voltage across the component. So B is wrong. C. An ammeter measures the charge per unit time. Charge per unit time is current. Yes, the ammeter measures the current. So A and C are correct. Answer 4. Question number 6. Two guitar wires A and B identical except the diameter. The diameter of A is twice the diameter of B. And they ask for the ratio fundamental frequency by A to the fundamental frequency by B. Fundamental frequency. That means the strings are vibrating at its fundamental mode. At its fundamental mode, you can draw a sketch. The strings are moving at its fundamental mode, so they have one loop. Fundamental mode has one loop. Then for that you can write lambda by 2 equal L, lambda equal 2L. For both the strings, lambda is 2L. So it means the lambda is same for both strings. Then the equation V equal F lambda. We use this equation for both the strings. VA equal FA lambda, VB equal FB lambda. Divide one by the other, VA over VB equal FA over FB. And you know that the speed of a wave in a string is given by square root of T over M. T tension, M mass per unit length. Mass of a wire is given by pi r squared L rho. Rho is the density. So mass per unit length is pi r squared rho. In the equation, V is proportional to square root of T over M. T tension is common to both the strings. So we can ignore T because we are using this equation twice and we combine these two. So it is not necessary to consider the common facts. So then V is proportional to 1 over square root of M. So M is mass per unit length. So it is pi r squared rho. Pi and rho also common to both strings, so we can ignore it. And from that we get v proportional to 1 over r. So for the A string, VA proportional to 1 over RA, VB proportional to 1 over RB. By dividing one by the other, VA over VB equal RB over RA. So before we have VA over VB equal FA over FB. So now therefore we can combine those two and write FA over FB equal RB over RA, and it is given that RA is twice of RB. So using that relationship we can have the ratio FA over FB is half. The answer is 2. Question number 7. Root means square speed of an ideal gas and the absolute temperature of the gas. How the root mean square speed and absolute temperature of the gas relate. Root mean square speed is proportional to the square root of the absolute temperature. Now for the question, root mean square speed to be doubled. Root mean square speed to be doubled, the absolute temperature must be 4 times of the given temperature. So the answer is 3. Question number 8. Angular velocity omega and time graph of an object is given. So it shows that omega increases with time linearly. Omega is rate of change of angular displacement. So that is omega equal delta theta over delta t. And in the answers they have given theta t graphs. Theta t graphs. The gradient of the theta t graph is delta theta over delta t. The gradient of the theta t graph is delta theta over delta t. Delta theta over delta t is omega. So omega increases with the time. So in theta t graphs, the gradient must increase with the time. So the gradient increases with the time is shown in the 5th answer. The answer 5. Question number 9. A major artery is carrying blood and that blood enter into 18 small arteries, and cross-sectional areas are given of those arteries, and it says they carry equal volume of blood per unit time. Volume of blood per unit time is given by AV. A is cross-sectional area, V is speed of the blood in a tube. So for the major artery we can write AV, that is 1 square centimeter into V1. V1 is the speed of blood in the major artery 1. And for a smaller artery we can write the same relationship. Volume of blood per unit time is 0.4 into V2, and it has 18 arteries. So the volume of blood per unit time in all arteries is 18 into 0.4 into V2, and this volume of blood flowing in the major artery and in all 18 small arteries are same. So we can equate the two equations. AV1, A1, A is 1 and V1 equal 18 into 0.4 into V2, and from that equation, we can get V1 over V2, and it is 7.2. The answer is 3. Question number 10. The diagram shows a wave pulse traveling along a string towards its end, and that end is connected to a small light ring which can be moved along a vertical wire. And they ask for the uh, best figure which shows the shape of the wave pulse at the instant when the peak of the pulse reaches the ring. Now the pulse is moving towards the free end. The light ring can be considered as a free end. It is not a fixed end, it is a free end. So at the free end, pulse reflects without inverting. So it reflects without any phase difference. So once it reaches, the pulse reaches the end, the same shape the reflected pulse has. So both pulses combine and give a higher amplitude, which is equal to 2. Answer is 2. Question number 11. A point object O is placed in front of a thin convex lens as in the diagram. They ask for the refracted path of the incident ray given in the diagram. Now in the diagram they have given only one focal point of the lens, and you can draw the other focal point of the lens at the right hand side of the lens. And to trace the refracted ray of the given ray, we take some known rays which are having definite paths of refraction. First, you can draw a ray which is passing through the center of the lens. So that ray goes without any refraction. And the next ray, we choose the ray which is parallel to the central axis. So that ray goes through the focal point at the right hand side. And you can lengthen those two rays, and they meet at one point, virtually meet at a point, and that point is at the side of the object, the same side. Object and that image are in the same side. So then connect that image point and the incident, the point of incident of the given ray, and then you get the answer. The answer is 4. Question number 12. A circuit is given. They ask for the current through the ammeter. When you look at this diagram, you can see it has 3 cells, and to find the current in the branches, we can use Kirchhoff's laws. And first we take the first loop and take the total EMF of that loop. So total EMF in one direction is 0, and for the other loop total EMF is 0. So there is no net EMF, so no current in the circuit. The answer is 1. Question number 13. A coil made up of platinum wire has a resistance of 50 ohm at 0 degree Celsius. When it is immersed in melting lead, the resistance of the wire increases, and that resistance is given, and the temperature coefficient of resistivity of platinum is also given. They ask for the melting point of lead. So you can use the equation R equal R naught into 1 plus alpha theta. the R is 115, R naught is 50, and in brackets 1 plus alpha theta, alpha is given. You have to find theta. The answer is 2. So circuit is shown in the figure, and a student by mistake replaces the ammeter with an ideal voltmeter. So now in place of ammeter there is a voltmeter. So voltmeter, they are ideal components. They are having very high resistances. So no current will pass through the voltmeters. That is, no current will pass through the circuit. And the voltmeters are in parallel with the cell. So both the voltmeters will show the potential difference across the cell, that is 2 volt. So it is 5. Answer is 5. Question number 15. The equation is given for a nuclear reaction, and the left hand side and the right hand side of the equation must be balanced with the mass number and the atomic number. So when you look at the left hand side, the atomic number is Z plus 3, and right hand side it has Z plus 2, and A should be 1 then. Atomic number of A is 1. And look at the mass number. Mass number of the left hand side particles is Z plus A, and the right hand side is 6 plus A, and the balance 1 must be there for A. So the mass number of A is 1. Atomic number 1, mass number 1. So it must be a proton. Answer 1. Question 16. A small conducting sphere, mass m, charge plus q. This sphere is hung from an insulating thread of length L, and this is in a region where there is an electric field. The intensity of the electric field is E, and the direction is downwards. So in addition to the gravitational field, there is an electric field also, and this oscillates as a simple pendulum. They ask for the period of oscillations of the simple pendulum. Now, you know, if there is only a gravitational field, the period of oscillation of a simple pendulum is given by 2 pi square root of L over G. So G is the acceleration. Now here the gravitational acceleration is G. Now here it has in addition to the gravitational field, there is an electric field also. So there are two forces on the mass, mg plus gravitational force mg and electric force eq. So the total force is mg plus eq. So if we need to find the acceleration of the affected acceleration on the mass. So we arrange this equation F equal mg plus eq in the form of F equal ma. So F equal, we take simple m out and put brackets. So we get F equal m in brackets simple g plus eq over m. So when we compare this equation with if F equal ma, it is clear that A equal, the acceleration equal simple g plus eq over m. So our the answer is then 2 pi square root L over the acceleration. Acceleration is simple g plus eq over m. Answer is 5. Question number 17. Two stars A and B, uniform density, equal radii. Star A having the having twice the mass of star B, and star A is spinning 3 times faster than star B. Now take A and B separately. B's mass is simple m and A is 2m then. For the angular velocities, for B omega and A 3 omega. And they ask for the angular momentum ratios. Angular momentum ratios. Angular momentum is I omega. I omega. So they ask IA omega A, IB divide by IB omega B. So I, the moment of inertia is proportional to the mass of the object and the distance square. So distance r is common in both stars. So we can write I is proportional to the mass. For A star, IA is proportional to 2m. For B, IB proportional to m. And in IA omega A, IB omega A, we have IA over IB. IA over IB is 2. And omega A over omega B is 3. The answer is 6. Question number 18. A circular disc of radius 0.5 meters rolls with a uniform angular speed on a horizontal surface without slipping. They ask for the speeds of the 2 points P and Q relative to the Earth when they are at the position shown in this figure. Now here Q touches the surface and the Q speed must be 0. P moves relative to Q. So P speed can be taken by R omega. Here the R is the distance from P to Q, that is 0.5 into 2, it is 1 meter. PQ distance is 1 meter. So R omega 1 into omega is 12. The answer is 5. Question number 19. The graph shows the variation of a force F exerted on an object when it's moving along the axis from x equal minus 5 to x equal 5. They ask for the work done on the object by the force. Now, when it's moving from minus 5 to minus 2, there will be no work. Why? There is no force. Work is force into distance. So, no force, no work. From plus 3 to plus 5, no force, no work. There will be work done on the object when it's moving from minus 2 to plus 3. Minus 2 to plus 3, the displacement is 5. So, force into displacement, force 10, displacement is 5. The answer is 50, answer 4. Question number 20. A box A, mass 50 kilogram, is placed on the horizontal floor bed of a lorry. The coefficient of the static friction between the box and the floor bed is 0.8. The lorry accelerates along a straight horizontal road. They ask for the maximum acceleration of the lorry so that the box will not slide over the floor bed. Now, when the lorry is accelerating, there will be a force on the box. So, that is given by MA. Mass of the box is given. Acceleration is the acceleration of the lorry, MA. So this box will not slide over the floor bed. That it implies that this force due to acceleration is balanced by a frictional force. So frictional force, it can be found by mu r by equating ma with mu r. You can find the answer for A. It is 8 meters per square second. The answer is 3. Question number 21. It is about a standing wave set up on a string fixed at both ends. So you to answer this question, you better draw a diagram for a standing wave showing the fundamental mode. So for the fundamental mode, it has one loop. Then if the length is L, you can write lambda over 2 equal L, lambda equal to L, and we'll see the answers. First one, the number of nodes is equal to the number of antinodes. No, by looking at the diagram, you will understand that nodes and antinodes are not equal. Answer 2, the wavelength of the wave is always equal to the value obtained when the length of the string is divided by an entity. No, lambda is 2L. Length multiplied by an integer, the right one. So 2 is wrong. The frequency of the wave is equal to the value of the number of nodes times the fundamental frequency. Now in your diagram you have 2 nodes, but the fundamental frequency, we say it is f naught. It is not 2f naught, it is f naught. So 3, number 3 is wrong. 4, the frequency of the wave is equal to the value of the number of antinode times of the fundamental frequency. Yes, now your fundamental mode of frequency is f naught, and multiplied by the number of antinodes. Antinodes 1. So 1 f naught. Now it is right. So the answer is 4. The shape, if you can think of the fifth one, the shape of the string at fundamental frequency is not symmetric. No, it is symmetric. 5 also wrong. So answer is 4. Question number 22. The question is about sound intensities and sound intensity levels in decibel. If the sound intensities of two sound waves is I1 and I2, and the ratio of the sound intensities will be I1 over I2. Then difference in sound intensity levels in decibel is 10 log I1 over I2. To get the answer for this question, we consider the given answers one by one. First, we take the first answer. It is 10. That is I1 over I2 is 10. And 10 log I1 over I2. 10 log I1 over I2 is 10. 10 log 10. Again it is 10. So I1 over I2 is 10, and 10 log I1 over I2 is also 10. So the answer would be 1. First answer. Question number 23. A telescope, its magnifying power is given and power of the eyepiece is also given. The question is to find the length of the telescope when it is in the normal adjustment. When a telescope is in its normal adjustment, its length is equal to FO plus FE. FO is the focal length of the objective lens and FE is the focal length of the eyepiece. Now here the power of eyepiece is given. We can find the focal length of the eyepiece. So FE equal to 1 over 50. You get FE equal 0.02 meters. that is 2 centimeters. Then magnifying power of the telescope is 15. That is FO over FE is 15. So FO equal 15 into FE. So FE is 30 centimeter. Then the length of the telescope is 30 plus 2, 32 centimeters. Answer 4. Question number 24. Two particles having charges plus q and minus q revolve in opposite directions with the same angular speed along two circular paths which are very close to each other. And the question is to find the magnetic flux density at the center of the circular path. First, we consider the motion of the plus q charge. Plus q charge moving to the clockwise direction. So, to find the magnetic flux density, the direction of the magnetic flux density, we can use the right hand grip rule. By using the right hand grip rule, you can find that the direction of the magnetic flux density is at the center is inside your book, is to the direction of your book. And the magnitude is given by mu naught I over 2r. And for the minus q charge, minus q is moving to the anticlockwise direction. So it implies that plus q is moving to the clockwise direction. So again, plus q, another plus q is moving to the clockwise direction. So that also gives the direction of the magnetic field inside your book, and the value is mu naught I over 2r. So the total magnetic flux density is 2 times of mu naught I over 2r. Then I is current, I is q over t, and omega is 2 pi over t, and with that you can find t equal 2 pi over omega, and current is then I equal q omega over 2 pi. Then by substituting q omega over 2 pi in i's place, we have B equal mu naught q omega over 2 pi r, which is 3. 24, the answer is 3. Question number 25. Three arrangements A, B and C are shown in the diagram. Three identical particles kept on a semicircle, and the fourth particle that is also identical with the other three is kept at the center of the semicircle. The question is about the gravitational force on the particle at the center. You can draw the direction of forces on the particle at the center of the semicircle, and then you can take the components in x and y direction, components of forces in x and y direction, and you can see at A the y component will be cancelled off because the two forces are acting in opposite directions. So only the force remaining is in the x direction. So one force is there. And for B, x and taking the x and y components of the forces, y component will be cancelled off due to the direction in opposite directions, and x component will be higher than A. And when looking at C, y component again being cancelled off, and x components, the total of the x components of the forces will be higher than B. So the answer is 1. Question number 26. 4-point charges and a Gaussian surface S is shown in the figure. Three statements are given. A. Net electric flux through the surface depends only on the fields produced by Q1 and Q2. Q1 and Q2 are inside the Gaussian surface. Q3 and Q4 are outside the Gaussian surface. So the flux, fields produced by Q1 and Q2 moves from inside to the outside of the surface. And the fields produced by Q3 and Q4 enter into the Gaussian surface and exit from the Gaussian surface. So not uh, net field due to Q3 and Q4 is 0. So A is correct. Net electric flux through the surface depends only on the fields produced by Q1 and Q2. It is right. B. The electric field intensity at point P depends only on the fields produced by Q1 and Q2. No. Electric field intensity at P depends on all the uh, all the charges. C. The electric field's intensity at point P depends on the location of the charges Q1, Q2, Q3 and Q4. Yes, of course, it is true. So the answer is 4. Question number 27. Which of the arrangements shown are equivalent to a NOT gate? NOT gate. Equivalent to a NOT gate is only NO or NAND. So the answer is 3. Question number 28. T1 and T2 transistors, they are silicon transistors. VCE values are given. For silicon transistors, we know that VBE value is approximately 0.7 volt. We take it as 0.7 volt. Now in each answer we have to find VBC. We have to find VBC in each transistor. So for T1, VBC equal 0.7 minus 0.1, which is 0.6, and it is a positive value. So with that we know that VB is greater than VE. For the T2 transistor, VBC equal 0.7 minus 3, which is minus 2.3. So with that we know VC is greater than VB. It's a minus value. VC is greater than VB. Now look at the answers. VBC must be 0.6 for T1. T1 VBC 0.6. Yes, the first and the third answers has VBC 0.6. And for T2, VBC should be minus 2.3. No answer with minus 2.3. So we have two answers, either 1 or 3. And now let's see whether it's forward biased or reversed biased. Now VB is greater than VE for T1. VB is greater than VE. It shows that it's a forward biased. So answer is A. Question number 29. A glass capillary tube of internal diameter D is immersed vertically in water. The water level inside the tube rises to a height of h. They ask for the variation of h with D. Now, when water in the capillary tube is at a height of h, so the pressure given by h height is h rho g, and that pressure must be equal to the pressure difference between the curvature of the water surface inside the capillary tube, that is 2T over R. 2T over R is equal to H rho G. Then T is surface tension. By that we can take H is proportional to 1 over R. H is proportional to 1 over D. D is diameter. 1 over D. So, H is proportional to 1 over D. Relationship is shown by the graph 1, 29.1. Question number 30. Two light rods of initial lengths L1 and L2. Cross-sectional areas are equal. These rods are joined end to end and force F is applied on that. They are asking for a relationship of the Young modulus and the original lengths of the rods. Young modulus is stress over strain. So, Young modulus E equal stress is F over A divided by strain is E over L. So, we have to use this equation to both rods. So, it is not necessary to take that common facts in the equation. So, looking at the equation, F is common, A is common, and they they say that same contract by same amount, E is common. Then we can get a relationship E is proportional to L. For the first rod, we can write E1 is proportional to L1, and for the next rod E2 is proportional to the L2, and by dividing one from the other, E1 divided by E2 equal L1 divided by L2. With that we can take L2 E1 equal L1 E2. So answer is 1.